Okay, so now we're looking at some review questions or some test type practice questions that you might see dealing with contextual problems with the scaling of areas. So we're going to look first at solving for scale factor in context, finding missing dimensions, and scaling areas in context. Just like last time, practice questions. Okay. So first one says, a telescope is found to magnify an image so that its area is increased by a factor of 625 to 1. So the area of the image then is 625, if you want, over 1 multiplied by the area of the actual. So what's the linear scale factor? Well, 625 has to be the area of the image over the area of the actual. Whoops. There we go. And that has to equal the squared scale factor. So the linear scale factor, K, will be the square root of 625, which I think is a quarter. So 25 cents on the money. Okay, lots of things to try and fool you up with reciprocals and forgetting the square root and all that here. Okay, so really I think, now I'm no expert on telescopes, but I think they would quote the magnification there as 25 times, even though it increases the area by 625 times. Isn't that interesting? Wow, math never ceases to amaze you. Rogers Centre in Toronto, let's go Blue Jays, is due for a resurfacing to replace its AstroTurf. A 25 square foot model with a scale factor of 1 to 100 is used in determining the budget for the endeavor. At a price of $10 per square foot, what will be the total cost? So we want to find out the area of the actual. And we've done this enough now that you should be able to say the area of an actual is what you get if you take the area of the image and you divide by your squared scale factor. Okay. So we're going to say the area of the image here was 25 square feet. And we're dividing by our scale factor, which is 1 over 100 squared. So that ends up being 25 multiplied by the reciprocal of that, which is 100 squared, or 10,000. So what we end up with is 25 times 10,000 is 250,000 square feet. Okay, that sounds about right though. Rogers Centre is pretty big. So 250,000 square feet, and they're going to charge a price of $10 per square foot. So what will be the total cost? So this is actually a rate problem thrown in there. So our cost is going to be equal to our, whoops, no E on cost. It's going to be equal to our rate multiplied by our area. So that will be $10 per square foot multiplied by 250,000 square feet. So cancel out our square feet, and we're going to have 250,000 times 10 is 2.5, or $2,500,000. So to put new AstroTurf in Rogers Centre, $2.5 million. Sounds like a lot of money to you or me. In fact, it is. But I guess if you own the Rogers Centre or the Toronto Blue Jays or both, then $2.5 million is not even a fraction of what some of those guys make a year. So, all right. Quick review. To quickly find a scale factor, just divide the areas and take the square root. Yep. To find a missing dimension, find your scale factor first, multiply if the dimension is on the model, or divide if it's on the actual. The area of an actual object can be found by dividing the area of the scale on the model, or diagrammed by the square of the scale factor. Hopefully all this is helpful, and we'll see you in the next one.